You are listening to The Vocal Technologist. Spoken tech for your ears.
Right now, we have AI models that can generate an entire application's code base in, like, what, 30 seconds?
Yeah, literally seconds. It's wild.
So why does it currently take platform teams at major companies 6 whole weeks to merge a single one-line configuration change?
I mean, it is the ultimate bottleneck. We've completely revolutionized how fast we write software, but the infrastructure and, the humans actually managing it are just buckling under the sheer volume.
Welcome to today's deep dive, everyone. We've got a really fascinating stack of sources for you today.
Yeah, a huge collection of recent technical newsletters, some new dev tools.
And a bunch of architecture articles all trying to map out this incredibly chaotic landscape we're in.
Right.
And our mission for this deep dive is really to figure out this massive contradiction. Like, we want to know why, in an era of infinite instant code generation, developers are burning out faster than ever.
Oh, for sure.
Why our deployment pipelines are absolutely choking, and why on earth we're still aggressively arguing about C-pointers.
Because the reality is, AI didn't erase the fundamental laws of computing physics. And it definitely didn't erase human psychology.
Well, it didn't.
We've introduced this God-tier abstraction, but we're still tripping over the exact same structural roots.
Okay, let's unpack this, starting with, well, the human element. Because AI isn't just changing the code we ship, right? It's fundamentally altering the psychology of the developer.
It really is.
There's this one detail across our sources that illustrates this massive shift for you. Nobody cracks open physical programming books anymore.
Yeah, they're practically extinct.
Generative AI and automated assistants have basically replaced printed manuals entirely.
Which, if you think about it, fundamentally changes the cognitive process of learning itself.
How so?
Well, when you learn from a book, you're forced to internalize the logic step by step, right? You build a mental model of the syntax.
You actually have to read it.
Exactly.
Yeah.
But now, developers are pushed to these much higher levels of abstraction. You aren't learning syntax anymore. You're just asking an AI for the instant solution and pasting it in.
Right, so you become an editor, not a writer.
Precisely.
And being a full-time editor is causing this totally new kind of crisis. There's that startling article we reviewed about AI-assisted engineers experiencing severe burnout.
Which sounds counterintuitive at first.
Totally. I was trying to figure out why, easier work leads to more burnout. And I think it's like, okay, imagine you spent your whole career training to be a master chef.
Okay, I'm with you.
You love the tactile process of cooking. You love the creative problem solving of balancing flavors.
You enjoy the actual craft of it.
Right. But then your restaurant gets a robot that can cook 1,000 meals a minute. So suddenly your job's no longer cooking.
You're just managing the output.
Yeah, your job is being the health inspector at a fast food joint. You're just standing at the end of the conveyor belt, constantly reviewing the robot's output to make sure it, won't poison anybody.
That's a brutal analogy, but it's so accurate. You're reviewing thousands of lines of AI-generated code. It causes massive cognitive overload, and it totally strips away the satisfaction of creative problem solving.
What's fascinating here is the psychological mechanism behind that specific frustration. We have an article highlighting how the lifelike nature of these coding agents actually works against us.
Because we treat them like humans.
Exactly, because they feel conversational, they trigger our human social instincts.
Oh, wow.
Yeah. So when an AI agent repetitively fails at a task, say, it keeps hallucinating a library that doesn't even exist, we don't just see a bug in a machine.
Right, we react socially.
We become visibly, genuinely frustrated because the agent lacks real accountability. I mean, it feels like a coworker's just ignoring you, but you can't reprimand a server.
It's infuriating. And this friction is leading to this massive ideological clash in the community right now.
Oh, the gen debate.
Yes. On one side, we have this piece titled Leave Me Behind, which argues that software development is this soulful human craft, right? Rooted in trial and error and connection. And the author argues we need to actively reject generative AI to preserve that art form.
Exactly. But then, directly countering that, we have the gen can never leave perspective.
Right, which looks at the practical reality of messy systems.
Yeah, like legacy payroll data. You almost always have a single human expert. Let's call her Jen.
And Jen holds all this fluid, undocumented wisdom in her head. She knows exactly which spreadsheet columns are broken, how to fix them.
She's the only one who knows how the duct tape holds together.
Right. And the author argues that when Jen is the only one who can interpret the data, she becomes a massive bottleneck.
Right.
So by using AI to process the standard files and encode Gen's unique human judgment into autonomous rules, you actually turn Gen into a force multiplier.
See, I have to push back on that logic, though.
Okay, lay it on me.
If Jen encodes all of her unique, hard-earned wisdom into an AI system that just runs autonomously, doesn't she just turn herself into a server?
It's a valid concern?
I mean, is she really a force multiplier, or is she just automating herself out of a job?
That is the exact tension you need to be weighing right now if you're navigating this industry. Whether you view AI as, like, a threat to the craft or a necessary evolution, your day-to-day role is morphing.
It's unavoidable.
One of our sources explicitly stresses that professionals need to proactively develop career optionality and AI-native skills before 2027.
Wow. 2 years.
Yeah. If you just stick to writing boilerplate code, your value basically drops to zero.
And we're even seeing that split in technical writing, actually. AI is entirely taking over basic API documentation.
Sure, it's great at the simple stuff.
But because it lacks deep domain context, companies still desperately need human technical writers for highly nuanced, complex architectural specs.
Which naturally brings us to the operational side of things. Because if AI is here to stay, and it's causing this much cognitive friction, how are the best developers actually wrangling it?
How do you command the machine without becoming the burnt-out health inspector? Well, you have to actually understand the anatomy of what you're dealing with. Let's look at the Hugging Face agent glossary from our stack.
Great resource.
It defines an AI agent not just as a single chatbot, but as a system of 3 distinct parts. You have the core language model at the center, but then you wrap it in a behavior-defining scaffold.
Right.
What does that scaffold actually do?
Well, the underlying language model is just predicting the next word, right? The scaffold is the programmatic wrapper that gives it a persona, constraints, and specific tools it can call.
Like giving it a calculator or a web scraper.
Exactly. But the most crucial part is the third piece, the execution-focused harness. This is where the agent actually runs code in a sandbox.
Okay.
The harness uses mechanisms like rollouts of reward systems.
Rollouts meaning the AI tries multiple different solutions simultaneously.
Precisely. A rollout is the agent exploring different decision trees. So it tries path A, path B, and path C.
All at once.
Yeah. Then the reward system automatically grades those outcomes based on predefined success metrics.
Oh,
So it learns which path actually compiled and worked, and feeds that right back into the model.
So it's a closed-loop system executing objectives, not just spitting out text.
Right.
And some engineers are taking a surprisingly manual approach to controlling this loop. Like, we looked at the workflow of Mark Erickson, a maintainer for Redux.
EXA.
He uses what he calls an orchestrator set up for his agents, and he isn't prioritizing speed at all.
Not even a little bit.
He prioritizes deliberate, deterministic control. He actually forces the AI to pause and wait for human confirmation at every major architectural step.
Which makes sense, largely because giving AI reliable long-term memory is still an unsolved gap.
Right. It'll just forget the architecture halfway through the project.
Exactly. He's enforcing rigid structure because generative systems naturally trend toward entropy. If you give them too much slack, they hallucinate wildly.
Here's where it gets really interesting, though. Developers are discovering that the best way to control that entropy is by pairing these super advanced LLMs with incredibly boring, rigid programming languages.
Like Go.
Specifically Go.
The contrast there is brilliant when you think about how machine learning models actually infer solutions.
Yeah, I was trying to figure out why Go over something like JavaScript or Python.
Because the ecosystems for JavaScript and Python are wildly fragmented.
There are 100 different ways to build a web server in Node.js.
Exactly. But a language like Go has extremely strong dogmatic conventions. There's usually only one idiomatic way to write a piece of Go code.
So from a machine learning perspective, you're drastically narrowing the search space.
Yes. The training data for Go doesn't contain a dozen conflicting paradigms. It offers clear mathematical guardrails.
So the AI spends less time guessing which framework you want and more time writing stable logic.
Right.
But even with a strict language like Go, the AI still needs context about your specific company. And an entire ecosystem of tooling is springing up just to give AI the context it inherently lacks.
Context is everything right now.
I was looking at Unblocked. It acts as a context layer by digesting your company's past Jira tickets, Slack conversations, legacy pull requests.
All the messy human stuff.
Yeah. It turns human chatter into an actionable knowledge graph, so the agent actually knows why a bizarre piece of legacy code exists before it just blindly tries to delete it.
And we're seeing this contextual evolution in databases as well. Oracle AI database is a great example here.
Oh, right, because of the vector search stuff.
Exactly. Normally, if you want an AI to search your company's documents, you convert that text into a mathematical array called a vector, and you store it in a specialized vector database.
Right.
But your actual user data is in a relational SQL database.
So when the agent needs both.
It has to query two entirely different systems, which creates massive latency.
Which is terrible for UX.
Right. So Oracle is acting as a unified memory core by mixing vector search, relational data, JSON, and graph data, all in one single query engine.
That's huge. And on the front end, we have tools like Skybridge emerging.
Yeah.
It's a full-stack React framework specifically designed for building interactive UI views in MCP-based environments. I actually had to look up MCP.
The Model Context Protocol.
Yeah, the Model Context Protocol. It's an open standard that lets models like Claude securely hook into your local developer environment.
Right.
Skybridge provides the scaffolding so you can build type-safe interactive apps that live directly inside the AI's chat interface.
It's amazing. But, if we pull back and look at the macroeconomics of all this tooling, it is completely upending global software strategies.
How so?
Relying exclusively on those top-tier, frontier models from OpenAI or Anthropic, it's becoming prohibitively expensive due to rising API costs and massive token consumption.
Oh, because the build just scales infinitely as your agents do more of those rollouts we talked about.
Exactly. So the market is pivoting. The new economical strategy is actually a hybrid approach,
Which is?
pairing lower-cost offshore engineering teams with affordable, locally hosted open-source AI models.
Wow, that shifts the whole dynamic. And that desire to move away from centralized, expensive models is happening at the national scale, too.
Well, the Norway project.
Yes. Norway's National Library is undertaking this massive project using 2 petabytes of Huawei flash storage to train their own sovereign LLM.
And they aren't doing this just to save money on API calls.
No. They're specifically building an AI to preserve their unique language, history, and cultural nuance.
Because if they rely on a generalized model from Silicon Valley, it's going to respond with American cultural biases.
Exactly. A sovereign model protects their digital heritage. Okay, so let's track the causality here.
Let's do it.
We've got developers figuring out how to direct AI using agents and rigid languages. We've got massive new databases giving it context, and we've got countries and companies spinning up localized models.
Right.
The direct result of all this is that AI is pumping out an unprecedented astronomical volume of code.
Volume like we've never seen.
But here is where we hit the brick wall. The infrastructure we use to actually test and deploy that code is buckling under the pressure.
It's a massive queuing theory problem. I mean, think of your deployment pipeline like a computer's CPU. The processor, the AI writing the code, is infinitely fast. But the I/O bus, the human code review, the testing, the CI/CD pipelines is tiny.
So you have a fire hose of code trying to push through a coffee straw.
Exactly.
And the data on this is staggering. Tidra interviewed platform teams at over 100 companies. Do you know how long a simple one-line configuration change takes to merge at scale right now?
I do, and it hurts.
6 weeks?
6 weeks of lead time just to get a single line of logic into production.
It's insane. The bottleneck has entirely shifted. Writing the code is trivial now.
Yep.
Getting that code merged, dealing with legacy tech debt, remediating zero-day vulnerabilities, ensuring it doesn't break a microservice 3 layers deep is a total nightmare.
And bulk PR scripts and IDE agents have completely stopped scaling to handle it.
So if AI is drastically driving up code volume, and it's even shifting the build versus buy math for mobile release tooling, which we saw with engineers from Spotify and Etsy recalculating their strategies, how on earth do we unblock the deployment pipes? I mean, I don't see how humans review all this.
Humans can't. We just can't. We have to fundamentally re-architect the build environments themselves to be instantaneous.
Is that even possible?
Vercel's recent overhaul is a perfect case study for this. They managed to cut their platform's build wait times from 90 seconds down to just 5 seconds.
Wait, what? An 18x gain in speed?
Yeah.
How do you shave 85 seconds off a build process?
By rethinking virtualization entirely. They built an internal platform called Hive, which utilizes AWS Firecracker micro VMs.
Okay, what does that mean in plain English?
To understand why this matters, you have to look at the security risk of shared infrastructure. Vercel runs untrusted code from millions of customers on shared hardware.
Right.
Using standard Docker containers is too risky because containers share the host operating system's kernel.
So if a malicious piece of code finds an exploit.
It can break out and compromise the entire server.
Right, so you traditionally use a virtual machine because it gives every tenant their own isolated kernel.
Exactly. But booting a full VM takes forever. Because it simulates an entire computer, like down to the floppy disk drivers.
Which takes way too much time.
Firecracker solves this. It's a micro VM. It provides the security boundary of a unique kernel, but it strips out all the legacy hardware bloat.
So it boots fast.
It boots in milliseconds. Vercel combined this with a warm pool of pre-booted cells just waiting for code. It gives you the ironclad security of a virtual machine with the instant availability of a container.
Wow. So it's brute forcing the speed barrier at the infrastructure level just to keep up with the AI code volume.
Exactly.
And we're having to accelerate our testing just to keep pace, too. Look at tools like QA Wolf. Instead of humans writing UI tests, it uses an AI agent to write playwright tests 12 times faster than traditional methods.
Mapping out hundreds of user workflows in minutes.
Yeah. And we're also seeing a massive push to modernize legacy overhead to squeeze out better runtime performance, like using the new code mod that automates the migration of Node.js HTTP requests from the Axios library over to the native WHA2WG fetch API.
Right, because Axios was necessary years ago. But now native fetch is built directly into the runtime.
Which means less overhead and faster network requests.
Exactly.
But, and this is a big caveat to all of this speed and abstraction, we can talk about AI agents and micro VMs and automated code mods all day long.
Sure.
At the absolute foundation of everything, we are still battling the exact same low-level hardware constraints and niche data quirks we always have.
Yeah, if we connect this to the bigger picture, it highlights a profound reality about computer science. Abstraction is mostly an illusion.
Right.
No matter how high up the stack AI pushes us, no matter how conversational the prompts get, someone, somewhere, still has to deal with the metal.
And the metal is unforgiving.
It really is.
Which brings us to the persistence of C and C++.
Yeah.
I mean, AI is writing Python scripts in seconds, but we are still dealing with the fact that C array types are incredibly dangerous and just weird.
They are notoriously counterintuitive. In most expressions in C, an array decays into a pointer.
Which blew my mind when I first learned it. If you have an array of 3 numbers and you pass it to a function, the program literally loses the length information.
Oof, gone.
It just hands you a memory address pointing to the first number and basically says, good luck.
Yeah.
It forgets how big the array is, which is exactly how you get buffer overflows and memory leaks. And to fix that, real-world C code relies heavily on non-standard language extensions just to bridge compiler gaps.
Which makes porting code across different operating systems incredibly painful.
Right.
And this leads to a persistent, dangerous misconception that C and C++ are easally compatible.
They aren't.
They aren't. They have entirely distinct object models. You constantly see developers trying to integrate legacy C constructs like the malloc function for raw memory allocation into modern C++i.
And that's bad.
Well, C++ relies heavily on strict ownership semantics and safety models. If you just drop raw malloc calls into a C++ code base, you break those safety guarantees. You have to carefully isolate those C-specific features.
It's just wild to me that we're still wrestling with malloc ownership while AI is out here trying to architect our entire backend.
It's the duality of modern dev.
But it just proves that the niche, hyper-specific manual engineering layer is still very much alive. Developers are still meticulously crafting bespoke tools by hand.
Because generalized AI models cannot solve highly specialized data workloads.
Totally. Let's look at some specific examples from our stack today that I just loved. First, there's Village SQL. It's a custom fork of MySQL.
Okay.
What it does is intercept MySQL queries at the parser level, allowing developers to create custom data types and extensions dynamically without ever restarting the server. Yeah, it basically lets you treat a standard MySQL database like a highly complex graph database, similar to Neo4j, but without the overhead of migrating your entire infrastructure.
That is a brilliant piece of manual engineering for a very specific architectural constraint.
Right. And then you've got tools like Orval, generating type-safe TypeScript clients directly from open API specs.
Super useful.
And then on the front end, you have Brownies. It's this super lightweight JavaScript library that tackles local storage. Normally, interacting with IndexedDB in the browser requires a ton of asynchronous boilerplate code, right?
Oh, it's a headache.
So Brownies uses JavaScript proxies to intercept your property access. You can treat complex browser storage exactly like you would a simple JavaScript object, and it handles all the async database routing under the hood.
It makes local offline data management almost effortless.
Yeah.
And speaking of local data, we're seeing a massive emphasis on data sovereignty and privacy in these niche builds. The broader the AI tools get, the more some developers retreat into privacy-first architectures.
You definitely see that with AnyType, which is a local-first encrypted collaboration platform. It gives users total control over their cryptographic keys.
Right.
And honestly, my personal favorite read from the stack was the Bootstrapper's EU stack.
Oh, that was fascinating.
It's a guide showing how a single developer can build a complete privacy-conscious tech stack fully compliant with EU data laws for under €10 a month.
It's just incredible.
They're manually piecing together tools like Simple Analytics and Tally to actively avoid the massive data harvesting of big tech platforms.
It proves that while AI is standardizing the broad strokes of software development, human developers are still meticulously crafting the finer, specialized details.
Even down to the typography. We reviewed a piece about modern pixel fonts.
Yes, the pixel fonts.
They aren't just retro 8-bit nostalgia anymore. Designers are creating technically refined pixel fonts specifically to fix historical legibility issues on modern, high DPI sub-pixel displays.
They're being used in highly professional, modern production environments.
The manual detail work truly never stops.
It's the persistence of craftsmanship. When the macro level becomes automated, humans obsess over the micro level.
So bringing this all together,
Yeah.
we have a mountain of conflicting realities here for you.
We really do.
AI is pushing us to high abstraction. It's causing psychological burnout, demanding complex new agent frameworks, choking our deployment pipelines, while the low-level C code and typography remain as stubbornly manual as ever. How do you actually navigate a career in this?
I think the most grounding piece of advice from our sources comes from James Cowling, a former senior engineer at Dropbox.
His insights on system architecture were incredibly clarifying.
In the midst of all this noise, the hype, and the AI-generated volume, his advice to developers is to aggressively focus on conceptual problem-solving.
Not the tools themselves.
Exactly. Stop obsessing over specific systems, languages, or AI models. Your job is to align the team's incentives with the actual business goals. And above all, prioritize simplicity over complexity.
Whether you're working with AI like the applied AI team at TLDR who are actively trying to make complex workflows legible to code, or if you're in the trenches manually isolating memory leaks in C++C, simplicity is the ultimate goal.
Always.
You have to focus on the overarching problem, not just the shiny new generative hammer. We're shifting from being syntax monkeys to being system architects.
This raises an important question, though. We established earlier that AI is abstracting away the mechanical act of coding. Our value as humans is shifting entirely to that conceptual problem-solving that Cowling talked about. We map the architecture, the AI types the syntax.
Okay.
But what happens when the models get good enough to abstract the concepts themselves? When the machine can proactively map the architecture, define the business logic, and write the code, what will be the soulful craft of the developer in the 2030s?
Oh, man. That is the existential question, isn't it? If
Yeah.
the blueprint builds the skyscraper all by itself and the AI decides what the skyscraper should look like, what exactly does the architect do tomorrow?
Exactly.
Thank you so much for joining us on this deep dive. If you're managing a platform team or just trying to survive the AI onslaught, keep exploring these tools, keep building simply, and most importantly, keep asking those hard questions. See you next time.
Spoken Tech for your ears.